We thought it was important to clarify what we actually mean when we say add noise to an image. One might expect that in order to go from here to here, you simply generate some noise and then add it over the original image. But it's not actually this simple. The diffusion process is modeled as a Markov chain, where the next image in the sequence is some random variation of the pixels in the current image. This is actually what causes the noise. In other words, you build a Gaussian distribution and then sample from it in order to get the next image. This is why it's called Gaussian noise. It's easier to think about a single pixel. First, you map the intensity of this pixel to a numerical value, and then build a normal distribution around it with a mean equal to that value. So if we extend this process to every single pixel in the n by n image in parallel, the next image in the sequence is sort of like just a single observation, a single point on some n by n dimensional normal distribution. Now, there's one more parameter that we haven't considered, the variance of the normal distribution. This parameter is actually predetermined and allows us to control the progression of the diffusion by specifying the variance at each step. For example, you might want the diffusion to start very gradually and then ramp up towards the end. Moreover, we said that the color of the pixel maps directly to the mean of the normal distribution. In practice, you actually scale this mean down a tiny bit in order to counterbalance the introduction of noise. Finally, I wrote a Python script which simulates this whole process so that you can see how each sequential image becomes more noisy. What you can hopefully see is how noise isn't really added, but more introduced by this resampling process.